This session is on one of the gas laws called Charles's gas law. Now, gases in general are basically empty space, and they are not nearly as complex as people. They have only 4 variables. The first variable that they have that we need to be aware of is how much gas you have, the number of moles. And that's the letter M, number of moles. The second variable is temperature. And temperature is always measured in Kelvin degrees. We just referred to it as Kelvin. The third variable has a number of units. It's for pressure. It can be in atmospheres. It can be millimeters of mercury or torr. It can be in kilopascals. And the fourth variable is usually in liters. It could be milliliters, cubic meters, but it's usually liters. There we have it. Now let's start with the Charles's gas law. What we do is I think of this as the hot air balloon law. We are going to deal with only 2 of the 4 variables. We're going to hold 2 constant. We're going to not vary the number of moles. That's going to be constant. They're fixed. And also the pressure will be the pressure of the day. And that's going to be fixed or constant. We can use these words interchangeably. So the variables that we deal with are temperature and volume. And in about 1780, in that range, 1785, a French scientist by the name of Laws.Charles discovered in exploring hot air balloons. At that time, there were a lot of hot air balloons across Europe, and he decided to make hydrogen, made enough hydrogen that he made the first hydrogen hot air balloon. And the date for that was about 1783, and that's Laws.Charles. Charles discovered a relationship between the gas and temperature, and that is as the temperature increased, the volume increased. It was directly proportional. That's a proportionality symbol there. Temperature increased, volume increased. And the relationship was, if you look at the chart on the right side, you see that the relationship is very much linear. As the volume goes up, the temperature goes up. And if we take 2 particular temperatures, let's say 50 degrees Celsius and 100 degrees Celsius, notice as the temperature doubles, what do you think will happen to the volume? You have a fixed amount of the gas. The temperature doubles. What do you think happens to the volume? I've seen this on tests. And the answer is this: it does not double the volume. When it goes from 50 to 100 degrees Celsius, that's a doubling. But the temperature must be in the Kelvin scale. So we're going to add 273 degrees to both of these Celsius temperatures. And that converts it to Kelvin. And this makes it 373 Kelvin. And this is 323 Kelvin. So look, this doubles. 50 to 100 is a doubling, but the same temperature in Kelvin is not a doubling. It only goes up about 15%. So the volume increase is only about 15%. The volume, in this led later on to the Kelvin scale, the volume for every 1 Kelvin degree increase, the volume goes up 1/273rd. So if you go up 273 degrees, or 273 Kelvin degrees, start at 100 and go up to 373, the volume will double. The relationship is this. Since you have a linear relationship, and we'll look in the graph here on the right, you see that as volume goes up, temperature goes up. And so you can say volume equals the constant, the slope, times temperature, and any volume over temperature relationship is a constant. Okay, V over T is a constant. So you could take a second point, V2 over T2, that's that same constant, so these are equal to each other. V1 over T1 equals V2 over T2. So you have an equation now to study the change, and this is what we do a lot in science, study the change of one of these variables with respect to the others, one unknown and three known. For instance, let's take a problem over here. Let's say we start with an initial volume of 2 liters, and we want to know the second volume. It's an unknown. And let's say our temperature starts here at 0 degrees Celsius. That's 273 Kelvin. That's the initial temperature. And we go up 100 degrees. So now we're going up to 373 Kelvin. The equation that we're using, we want to isolate, solve for V2. So V1 over T1 equals V2 over T2. And we want to isolate V2, so we'll multiply both sides by T2. And we get an equation, V2 equals V1 over T1 times T2. Put the numbers in. The initial volume is 2 liters. Initial temperature is 273 Kelvin. The final temperature, T2, is 373 Kelvin. Kelvin cancels out, so we have 2 times 273 divided by 373, and that comes out to about 2.73 liters. So you see, once again, we've gone up 100 degrees, but Kelvin, but the volume did not double, of course. It's 2.73 liters. So just to review, the Charles's law says the volume is directly proportional to Kelvin temperature. That's very important to remember. Kelvin temperature must be used all the time. We'll scribble that in here. Kelvin temperature must be used all the time. And we can solve for the relationship of V1 over T1 to V2 over T2 for any problem. We can use any volume units, but the temperature units must be Kelvin. And we will stop right there.